This screencast introduces you to the hexadecimal and the binary system. This is important when you want to do computer programming and especially embedded system programming. Let's start with what we use in our daily lives, which is the decimal system. In the decimal system, all numbers are to the basis of 10. So let's say you have a number like 3,421. So what happens is you have 3 times 1,000, 4 times 100, 2 times 10, and 1 times 0. If you look at this is actually 3 times 10 to the power 3, 4 times 10 to the power 2, 2 times 2 to the 10 to the power 1, and 1 times 10 to the power 0. So you see this number is expressing to the factors of the basis 10 and adding them up. So if you add these things up, actually this is of course 3,000, this is 400, this is 20, and this is 1. You actually get 3,421. So this is the decimal system, and deci actually means 10, so because it's to the basis 10. Now, in the computer programming world, there are two important numbering systems. Is the hexadecimal and the other one is the binary system. Let's start with the binary system. The binary system actually comes from the fact that in electronics, digital information is actually 0 or 1. And 0 means off and 1 means on. Now, we know that the decimal system is to the basis 10 because there are 10 different values. They go from 0 to 9. So these are 10 different values. Now in the binary system, we have only 2 different values. So what happens? You have a number like 1011 in the binary system. Now, if we just use the same logic that we applied to the decimal system, this must be 2 to the power 0, this must be 2 to the power 1, 2 to the power 2, and here 2 to the power 3. What are these numbers? So let's write that down. This is obviously 1, 2 to the power 1, 2, 2 to the power 2, 4, 2 to the power 3, 8, and so on. Now, what we can do the exactly same thing. If you look at this, we see that we have 1 times 2 to the power 0, we have 1 times 2 to the power 1, we have 0 times 2 to the power 2, and we have 1 times 2 to the power 3. This is actually 8, of course. 2 times 2 times 2. So adding them all up gives us 11. So we know that this number in binary becomes 11 in the decimal system. Now, for notation, what we usually do when we program, we write 0b in front of the number to indicate that we mean a binary number, and if we don't put anything in front of it, we actually have decimal systems. Now, where you use such a number system a lot is when you want to write, for instance, port also of your microcontrollers. So in the first electronics workshop, you actually learned that you can access the pins of your microcontroller via a variable that is associated with the port register. And in the ATtiny that you're using, there's actually only one port, which is port B. And now port B is an 8-bit variable, so it can carry 256 different values, and it associates each of its bit with one of its pins. So you have PB0, which is the first pin, then you have PB1, which is the second pin, and so on. So if you want to turn on an LED, for instance, that is at port PB2, what you would need to do is you would actually have to say port B equals 0B 1 0 0. Now what happens is, this is the first bit 0, so it's off, second bit is off, and the third bit, which is associated with PB2, is 1. Now the thing is, it's not very nice to write something like 0B100, and especially it's not very nice if you have a full 8-bit register and you want to set this to some value like 10110000. So what you can do is you can actually convert this to the decimal system. And how do we do this? This is the 1s, these are the 2s, and these are the 4s. So there's actually no 2s in here, no 1s in here, so 1 4 in here. So this is actually 4. How do you do that here? Well, these are the 1s, the 2s, the 4s, the 8s, the 16th, the 32th, the 64s, and the 128s. Now what you can do, you can add up 128 plus 32 plus 16. What is this? This is 130, 160, 170, 176. So if you want to set a complicated value like this, you can actually just write port B equals 176, and what will happen? These 3 pins will be turned on, or these 3 pins that correspond to those bits. So that's PB7, PB5, and PB4. Now, what is better? 176 is easier to write, but you actually don't see anymore which pins you are setting. Now, decimal system. The hexadecimal system has a base 16. And this is, so hexa means 16. And there are unfortunately only 10 different numbers, 0 to 9. So what you do is you just use characters instead. So we go A, B, C, D, E, F. So this is hexadecimal and this is decimal. So you have 0 to 9 obviously, and then you have 10, 11, 12, 13, 14, and 15. So now you have 16 different numbers in the hexadecimal system, while you have only 10 different numbers in the decimal system. And so when you think now about the binary system, you will remember that the first 4 bits actually also go just encode 16 different values, because this was 1, this was 2, this was 4, this was 8. So adding those up will give you 8 plus 4 is 12, plus 2 is 14, 15. So if you set all 4 bits to 1 in binary, gives you 15 in decimal. Now the interesting thing is that if you wanted to set something complicated, 13 in hexadecimal was actually D. 0B10110000. You can very easily convert that into hexadecimal by looking at it in blocks of 4. And so this block is 0, and this block is actually in decimal 1 plus 2 is 4 plus 8. So 8, 12, 13. So you have this block corresponds to 13, this block corresponds to 0. Now what was again 13? We can write 0xd 0. And so 0xd 0 in hexadecimal is equivalent to 0b1000 in decimal, in binary.